All right, so here is example 5b. We've got a huge angle, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10 degrees, right? Degrees, because we call this little unit of measure the degrubble. Yeah, if you so like. Okay, the degrubble. Now, again, I can type that in 4, 5, 6, 7, 8, 9, 10. And since it's a positive angle, I can, let me store that as X. Okay, I can just say, okay, minus 360, enter, minus 360, enter. And all of these huge angles are coterminal, right, with this one. And now I've done it twice on my calculator. I subtract the 360. I can just keep hitting enter, enter, enter. So all of these angles on the right side of my calculator that are popping up are all coterminal with each other, right? This is not a very efficient way, though, to get it down to the positive angle that lives between 0 and 360. That's pretty typically what I'm going to be interested in. That positive angle that lives within one positive rotation from 0 to 360. So again, this is going to be more than 79 rotations that I did on the previous one. Now, you know, if I'm bored on a Friday night and I'm not sick, if I'm feeling well and the phone is not ringing and I can't go anywhere, you know, I might as well stay in and just do this, right? But there's better things to do, right? Like watch Corpy's old videos of new stuff or old stuff that we are still unsure on, right? There's a little plug for my free videos that y'all all have access to. Let's just go back to X, right? Boom. That number, if you want to know for size, right? 45 million degrees. Woo! Caliente, calor, whatever, right? That's not the right context. So there's the number. I'm going to divide by 360. Boom. And that's going to give me 126,885.8611. So I don't really need to show the divided by 360. If you want to do the stoichiometry like I did on the previous, that's fine. But really, just divide by 360, get that number. What is this number? What are the units? That's rotation. So I'm just going to put ROTS behind it. Do I care about the first 126,885 full rotations? No, that just lands at the same spot. So to let the calculator store the decimals, instead of just typing in 0.8611, which is really what I'm interested in, I'm actually going to just hit minus 126,885. And when you hit enter, oh crap. Yeah. Oh, I gave you 2 as well. Yeah. Sorry. Yeah, I did. Let me divide it by 360 again. All right, you got to make sure you're putting all the decimals in, right? 126,885. You should see 0.8. Oh, I'm an idiot. Yeah, I'm an idiot. You can agree with me. It's okay. I'm an idiot. My wife never lets me have my way. That's okay. Because she's always right. There, hey, little ditty I made up. I want the 0.8611111111, right? So that's rotation. So this is actually 0.86111111 rotations. I want to know what that is. So I'm going to multiply that by what now? 360 degrees. The same number I divided by. And that's 309.9999999999996. Yeah, it's a good song. Sing it with me, Brady. Come on, just get on camera. 309.999999996. And then it's a 6, right? So yeah, remember who's the boss of your calculator? You or your calculator? Yeah, you are, right? Your calculator is just like working on your behalf. So is it possible to start with an integer angle that has no decimals, divide out full factors of 360, an integer, and end up with a decimal? If I take a number,
it's like so close.
If I take a number that's an integer and I just keep subtracting integers from it, am I ever going to end up with a decimal? 10 minus 1 is 9. Minus 1 is 8, 7, 6, 5, 4, 3. Is that ever going to turn to a decimal? No. So your final answer is not a decimal. This is your calculator's way of saying to do what? Round up. Remember, I told you if you ever see like a 9, like at 3 nines and then maybe an 8, that's your calculator's way of saying round up. If you ever see 0.000, and then another number that's either a 0 or a 1, that's your calculator's way of rounding down. So just say, all right, thanks, calculator. This is degrees. So we know that theta, the angle we want, is 310 degrees. Okay. And that lives between 0 and 360. So it's kind of fun, right? Here's all we did. We divided by 360. We subtracted out the full rotations. We multiplied by 360. And then we interpreted it. Okay. So report that answer. So my intermediate work is shown there, but I have different units on it. So it's okay. If you want to show the whole process, that's fine. Now on this one, we didn't have to come back and add 360 at the end like we did on part A because we started with a positive angle. If we started with a negative angle, this would be negative 310. And then we want the other one that's coterminal. So let's just quickly graph where positive 310 is. There's the initial ray, which you don't even have to draw it. There's 180. Here's 270. 360 is too far. There it is. So I'll just label that as theta. That's all you're going to have to show.
Isn't theta the other one since theta is the unknown?
Yeah, that's why I called it theta.
But that's the angle we do know. That's angle 110.
Oh, that's the one I told you to find. Right? It says to find theta that lives between 0 and 360. Now, if you want to find the other fella, let's give him a different name, like dastardly dog of X. Let's call him alpha. What would alpha be? Gets to the same terminal ray, but instead of going all the way around, goes straight down.
Negative 50.
Negative 50. How'd you get that so fast, Brady?
Minus it by 360.
Yeah, if we're at 310 degrees, all you got to do is now subtract the full rotation. Minus 360, boom, and there it is. So alpha and theta are what with each other?
Coterminal.
Very good. Negative 50 does not equal 310. They're different, right? But they are coterminal. All right. Any questions on that? We'll call that the lesson for the day. We'll get into reference angle here probably tomorrow. So I'm going to stop this.